In this session, we'll see how the speed of induction motor is controlled. We'll not go into the details of the speed control systems. We'll have just an overview of speed control methodologies of induction motor. We know that the synchronous speed of induction motor is 120 F by P. So if we can vary F and we can vary the P as the frequency and the force of the induction motor, we can control the speed of we can control the rotor speed as well. We know that poles can either be 2, 4, 6, 8, so on, and at a rated frequency of say 50 Hz, the synchronous speed will be either 3000, 1500, 1000 RPMs, and so on. So corresponding to pole, if we have two poles, our synchronous speed will be 3000 RPM and our rotor speed will be definitely less than the synchronous speed. Corresponding to four pole system, uh, we'll have a synchronous speed of 1500 RPM and our rotor speed will be less than that. Corresponding to six pole, we'll have a synchronous speed of 1000 RPM and the rotor speed will be less than that, and so on. So by changing the number of poles, we can change the speed of the rotor or the speed of the rotation of the induction motor. The disadvantage of this system are that we'll be getting some selected speed levels only. We cannot control anywhere between 1500 and 3000 RPM. We cannot control between 1000 and 15 RPM. Since the number of poles will be fixed, the synchronous speed will also be fixed. So we'll be getting some selected levels. Secondly, it's difficult to arrange the windings to change the number of poles. We can have a system for that, but usually designing the winding in such a fashion so that uh, we are actually designing the starter windings so that we can create two poles, four poles, six poles, eight poles. So designing the winding in such a fashion or changing the winding to different number of poles is a tedious task. So the second method here is by changing the frequency, we can change the speed as well. So synchronous speed is inversely proportional to poles. As the number of poles increase, the synchronous speed will decrease. But synchronous speed is directly proportional to frequency. So as the frequency increases, the synchronous speed will increase. Uh, that means we can change the frequency by using converters, cycloconverters. We can change the frequency of the input source easily using cycloconverters, such that we produce variable frequency drives. By using variable frequency drives, we can easily change the frequency and easily change the synchronous speed of induction motors. So nowadays, the modern variable frequency drives are employed. Uh, they find increased use in systems such as in industries, in electrical vehicle drives, and so on. To mechanically change the frequency input to an induction motor, we can use rotary machineries. Uh, Such type of machines actually are able to produce different frequency levels. Again, we'll be limited to certain frequency levels only, and we will not be able to get wide range of speed variations using such devices. Other methods of speed control include we can change the armature voltage We can change the voltage supply, the voltage input. As we change the input voltage to a stator, the induced the magnetic field, the magnitude of magnetic field will be changed. The induced EMF in the rotor will change. If reduced voltage is induced in the rotor circuitry, the speed will be less. So speed is directly proportional to the voltage applied. So greater the voltage we apply, the greater will be the speed. Lesser the voltage we apply, lesser will be the speed. So by changing the armature voltage, we can control the speed of the induction motor. Uh, there's a limit to this, however, we cannot reduce the voltage beyond a level where our current increases beyond the rated current of the induction motor. Such a case will actually cause the motor to burn out. Other methods of speed control will also include resistance control methods. We can incorporate more resistance into the rotor windings. By increasing the resistance, we can decrease the rotor current. We can change the value of rotor currents by changing the resistance of the rotor circuitry. By increasing the rotor current, we can increase the speed, and by decreasing the rotor current, we can decrease the speed of the rotor. Now, this is possible in case of wound-round induction motors, as already discussed earlier also. We can easily change the resistance of a wound-round induction motor. But in case of spiral cage induction motors, it is not possible to change the rotor resistance. Uh, by rotor resistance, we are actually changing the rotor current. If rotor current uh, is increased, the speed will increase. If rotor current is decreased, the speed will decrease. In the next session, we will discuss the single phase induction motors, the starting of single phase induction motor.